you all day AICT sponsored 6-day online STTP on cyber criminology and network security. On behalf of Gopalan College of Engineering and Management, I welcome you all and our today's speaker. Today our eminent speaker is Dr. Senthil Kumar sir, and the topic which the sir is going to take is about malware signature analysis and classification. Before start the session, I'll give you a brief introduction about our eminent resource person, Dr. Senthil Kumar sir. Dr. Senthil Kumar sir currently serves as Associate Professor at the Department of Computer Science and Engineering at Amrita School of Engineering, Amrita Vishwavidyapeetham, Coimbatore. His research interests include video analytics, big data analytics, intrusion detection systems. He completed his BTech from Sethu Institute of Technology, Madurai. He then completed his MTech in Distributed Computing Systems from Pondicherry Engineering College, Pondicherry. He completed his PhD in Information and Communication Engineering from Anna University, Chennai. He has received appreciation in Indian Express for agent-based programming for banking domain. He has published various papers in like 9 national conference, 12 international conference, 14 international journal and 10 edited book volume. He has 22 Scopus publication in his hand. He has published a book on C++. He is a reviewer for Elsevier Computers and Electrical Engineering Journal. He is a guiding scholar with Amrita Vishwa Vidyapeetham in the area of video analytics intrusion detection system. He teaches courses in video processing, video analytics, machine learning for big data. He has involved himself in coding in the competence areas of programming like MATLAB, NS2, JST, .NET, Android, Hadoop, Spark, OpenCV with Qt. He is working with Amrita Vishwavidyapeetham, Coimbatore since 2001. He has membership in professional bodies like CSI, IETE. He has funding projects in his hand titled Malware Detection using FPGA, Sandboxing and Machine Learning Malware Detection. I wholeheartedly welcome you sir for this session.
Okay.
Now I request sir to continue this session.
Okay. All and thanks to Gopalan College of Engineering for hosting me for a session, and my sincere thanks to your principal, Dr. Sengotin sir, for keeping the belief in me and providing the opportunity to deliver the talk. And thanks to Manju ma'am and thanks to the other coordinators who have accepted that I can also be part of this session delivery for this course. Okay, so let me say what is the plan for the session today. Today's session plan is I want you to just understand what is malware analysis and just see a couple of outputs or demonstrations about how malware analysis is being done. If you ask me like what I closely work with respect to malware analysis, I have a funded project from IBM where we look at understanding how malwares can be analyzed by using deep learning approaches. So we had a funded project back in 2017 and we got this extension project back in 2019. So this is the second iteration of the project. So this is how I am related, or I can also speak in the area of malware detection. Okay. So let's start with the discussion.
Sir, your video is not on, and I hope you have not shared your PPT yet, right, sir?
Yeah, I've not shared the PPT, ma'am. Video, I'm just putting it on. After a couple of minutes,
okay,
I'll put on the video. I'm now starting to share with the PPT, right? Okay. So whatever you are having as clarifications or doubts, you can start putting in the chat message. I'll feel free to clarify you, and hope we have a good learning from both the sides. Okay, that's a plan for today's session. So I've shared the screen. I think you should be able to see my slide. Ma'am, are you able to see the slide?
No, sir, not yet.
One second.
Loading.
I think now it should be okay.
Yeah, yes, sir. Yes, sir.
Okay. See, the topic for today's session is malware signature analysis and classification. We would like to look at it as a hands-on session. So let's get into the insight of why we talk about this and what is so interesting about this malwares. So the agenda for the session would be is like we will look at the basics of malware. Then we will see what are the tools that are generally there for monitoring. There are many tools that are there for monitoring. So we will look at a couple of tools. Then we will discuss about uh, given a data set which is there for malware analysis. Okay, how do you build models, and using the models, how can you analyze the signature of the malware? Right. So here we will look at one set of algorithms for today's session. So given the time, we will look at algorithms on deep learning also in the next part of the session. Okay, my acknowledgement to my bachelor students in engineering and my PhD scholars. So I have two PhD scholars who work on behavioral security. They are working more related to malware as classification and web phishing attacks. So my acknowledgements to them. So because certain contributions that we present is more related to what they have been supporting us in the long term. So the first question somebody would ask is, what is a malware and why everybody is talking about malware nowadays, right? So we will take on through that. I'm just presenting in a way in which I have walked through the understanding of malwares in the projects and research, right? Some things may be very basic, but you can always sit back and listen, and that will get you complete understanding of the concepts. So the first thing somebody would ask is, okay, what is a malware? Then people will say that the expansion of malware will be malicious software, right? So what can a malware do? A malware will be able to disrupt any computer operation, will be able to gather some sensitive information which is there in your computer or in your network, or it can gain some access to private computer systems. What is this private computer systems means? Legacy systems that runs in the industry. For example, Citibank all of a sudden says, it's for an example I'm saying, all of a sudden says that their network is hacked, right? So that means that private legacy systems that they have developed has been hacked. Okay, so who is hacking that systems? Is malwares are hacking that systems, right? So what is there in a malware? That's the next question somebody would ask. A malware can actually have a code, it can have some scripts, it can actually have some active content which it can deposit back to the end systems. For example, if you say that I have got a malware in my computer, the end result of a malware would say that yes, I have a code. The code is now running in your system without you knowing the code is running, right? Now, the recent type of malwares that we are seeing nowadays is malwares which can actually use your computer resources. For example, if you have a good computer and the computer is having 16 GB RAM, I'm just talking for an example, right? It has 16 GB RAM, but your system is very slow, right? But you are having less data in your computer. So that case, people are saying that malwares come to your computer, they stay in your computer, and they actually run programs which they want to run in their host computer. For example, I want to run my program. I don't have a powerful computer. I can actually deposit a malware. That means I can host a malware on your computer. If your computer has a powerful resource, I can use that resource without you knowing it, right? It's like stealing of computer resources, right? This is a new type of attacks that are coming up. The next is, when you look at malwares, people talk about possibility saying that why do you have malwares, right? There are two ends of discussions. One is actually when you say that you have created a malware and you're able to steal some data, that is generally taken as something which is non-ethical. But in certain countries, it is totally different. People actually appreciate the possibilities that people are able to write programs through which you are able to steal somebody's data. In other way, the countries are trying to say that the more the possibility of stealing happens, the better programs are created to make sure that the data is more secure, right? So it's a win-win situation. So malwares as such can take any type of information which is possible in your computer. What are the types of malwares, right? Okay, so there are many types of malwares. More common which people would have heard is virus, Trojan horse, then worms, then spyware, zombie, phishing, then spam, adware, and next is ransomware. In this now, the most possible problem that we are happening nowadays is this phishing, right? This phishing is most challenging because you are accessing your web page, but what happens is without you knowing that you are trying to type your data, somebody is stealing your data. So if you ask me, okay, what would be a web phishing concept, right? So if I say that, okay, I have a State Bank website, okay, I just go to State Bank website and I have my login. I go and type my login, right? So I just go here and I am typing my login and password. Once I type my login and password, right, without me knowing that the data is being stolen, somebody steals my data, right? So what might happen is like the program might try to supply the login password that I have given, right? And might try to steal the money that is there in my account. Okay, this is now becoming very challenging. In fact, what happens is most commonly when people try to type a website, they get more websites which are similar to that websites. Okay, so this is one, please everybody be very work with websites nowadays. Web phishing is becoming very possible, and there's a lot of possibility that your data can be stolen. And if it is the data belonging to your bank account, I think you can imagine what will happen, right? It is not your money, it becomes somebody's money at one point of time, right? So next, when people say that I want to work only with more on virus, okay, I want to work on virus, then there's a website here which is called as Virus Total. There's a website called as total.com. If you go to this website, you'll get all possible viruses that are there, okay, and you will be able to analyze the signature of the viruses. So in case you want to understand what is there in a virus and what is the signature of a virus, please visit this website, virustotal.com. You can create a login and you'll be able to find what are all the latest viruses that are coming up, right? So virus, everybody knows the possibility of a virus is it can replicate themselves. And mostly people always give the statement saying virus is man-made. Reason is whenever a virus comes up back to your system, you can find the antivirus software also releasing a file which can actually take care of handling that virus. So virus generally is a man-made one, right? So there are many type of virus. The most problematic virus that I as much know is the directory virus. I think people would be knowing, right? Once this virus comes to your system, automatically there are shortcut folders getting created. So this is one possible virus that is always dangerous to your system. Next one is Trojan horse, which everybody knows. Trojan horse as such will not replicate, nor it will copy itself, right? But what happens is it will compromise the security of your system, right? So if you say your system is secured, but what happens is if a Trojan horse has come up to your system, then automatically the security of your system becomes a question, right? So what does a Trojan horse generally does is it captures your login and password, right? If you have your application running and if you go and type your username password, then your Trojan horse can actually capture your login and password, right? Then there are different type of Trojan horses. Example is remote access Trojans, backdoor Trojans, IRC Trojans, key logging Trojans. In this, the most difficult or dangerous one is basically the key loggers, right? Key loggers as such will capture your logins, passwords, right? So this is one which is little more risky as far as Trojan horse is concerned. The next one is worm. As far as worm is concerned, it will be a self-replicating program, right? As far as the worm is concerned, it can actually copy the whatever you want to have, right? And it sends the copies of the same program to the other computers also in the same network, right? Okay. And worm as such need not attach to any program. Virus is not like that. When you say a virus has come to your computer, it will automatically attach to some program. But worm is not like that. It need not attach to any program. It can work individually, right? The next one is spyware. Spyware as such will collect information without your knowledge. The information that it can collect is something which can be your username, passwords. The most common type of spyware that we have been hearing in the past is if you type your Gmail account user ID password, or you have your Yahoo account user ID password, without you knowing, the user ID password is stolen and it is sent back to some remote system. That's an example of spyware. The next one is zombie. Zombie as such will actually take control of your computer, right? And it will automatically connect to the internet And once it is connecting to the internet, what happens is your computer is attacked. Okay, that means your computer is compromised. So there's a lot of possibility that somebody can access your computer to do some malicious activities. It can be something like somebody can access your computer, can actually try to send a, right? Or it can access your computer to access a website which is not allowed on the internet. Let's take, for example, there's a website which government says people should not access. If you access, you are supposed to be a suspect in the country. So what a zombie can do is can attack your computer, compromise your computer, and as a result, it can make your computer can to access that website which is not allowed, right? That's what a zombie can do, right? So it's more like performing criminal activities with your own computer without you knowing it. So that's what is about zombie does. The next one is phishing. Phishing, as I told you, it's like you are trying to access some information about your website. As I was talking to you more commonly, you log into your website of your state bank or some other account without you knowing somebody is trying to access your login password. So that's what is called as phishing. This is more connected to web, so we generally call it as something called as web phishing, right? Okay, so this is just an example. Somebody is trying to access a content on the internet. Okay, whatever you're trying to access, somebody can steal your content. The next is spam. Spam, which everybody knows, right? In all your mail account, you'll have a spam folder coming. It is actually a mail which you are not asked for, but starts coming up again and again, right? So spam mail is something very, very different. Usually, the challenge with spam mails is you cannot categorize the spam mails. Even now with the today's web outlooks or folders that you have, sometimes in your common inbox also you get your spam mail. So once you click on it, the software will say, it looks like a spam. Do you want to move to the folder, right? So people who want to create spam files, they are creating in multiple ways, right? So spam is other one which is always called as a malware. The advantage is very hard because spam as such cannot be categorized at all. Well, once you click on a spam mail, automatically there is a virus or there can be a worm that can come back to your computer, right? So that's the difficulty of having a spam. The next is adware. Adware is basically advertising supported software, right? Okay. So you get some pop-ups, right? This people are now at least familiar, but if you ask people like me, when I graduated back in 99 and all, when we used to open a website, it says, click this, you get 1 lakh. So we have a consciousness to see that, okay, what is that 1 lakh that we can get when we click that particular pop-up? So once we click it, it goes and asks, okay, what is your user ID password? Once you keep on giving, finally your data is stolen, your account is blocked, or what, something malicious will happen. So that's an example of what adware is. Adware is something like which is malicious, but people want to get with the malware, right? Okay, so even though every one of us is intelligent, you can ask everybody, at least once they would have tried to click a pop-up icon which says that, okay, you have a bonus, you got a lottery, you get 1 lakh, click on this button and so on. So adware is actually advertising supported software. Okay. The next is ransomware. Ransomware is very hard to handle. Ransomware, what it does is like it actually restricts the user access in a computer, right? What does it generally do is it does an encryption on the original data itself. So if you have some files in your system, what happens is it encrypts the data, right? Once it encrypts the data, then automatically the data is encrypted. So people cannot see what is the original data, right? So it is indirectly what it is trying to do is once it encrypts the data, it has got control on your data also. So that's what a ransomware does. So this is just a quick view of what are all the different type of malwares, right? When we say malware is malicious program, the malwares can be in any of these categories. Now, the next question somebody would ask is, okay, how does a malware spread? Okay, right? So when you say malware is getting spreaded, it means that it is spreading from your computer to another computer to another network and then to outside the network that is on the internet, right? So naturally people will say that I have a pen drive, so I have a virus, so I put the same pen drive on some other system, that automatically my virus has come to the other system, so it's got spread. Somebody says I got a pirated software, right? So once I install the pirated software is installed, along with that malware is also getting installed. I'm on the social network, I'm on the Yahoo Mail, for example. I click a spam mail, automatically a malware lands to my system, right? That's an adware here. So that's also a possibility. Then, as usual, we told you when you work on mails or websites, there are possibility for malware to come back to your system, right? So what kind of malware can do very intelligently would be is like, this is something which industries always keeps a question. If you ask certain companies, the companies will say, my software got crashed, my files got crashed, right? When you say your software has got crashed, that means your program is not working, right? That means there is a virus that's come to your program which is not making your program to work, right? The other one, what people say is like, my files have got crashed. When you say your files have got crashed, it means that your files have got deleted, right? And there is possibility that the files deletion is very high, that you cannot recover the data itself. So it results in something called as data loss. So the first type of damage a malware can bring in is called as data loss. The second type of damage, as I told you, you have your account, you have your password, but without you knowing, somebody steals it. So that's an account theft here, right? Somebody's trying to steal your passwords or your account details. The third one is botnets, right? What is a botnet? Would be something like you are trying to take control on a computer. That means your computer is compromised. Your computer is not under your control, right? That means your computer now becomes a bot or a zombie, right? So that's the next one. So when you have computer which can be compromised, there can be multiple computer in a network which can also be compromised. So you say that your computer is not compromised. Indirectly, you are saying your network is compromised. That means your network is attacked. Okay, so that's where we talk about something called as botnets. So the third type of damage that might come up is botnet. The fourth one is financial loss, right? As I told you, if your malware is going to attack a bank account, then automatically money is going to go off, right? So naturally, there's going to be financial loss to the person who has been attacked with the malware. That means a person's account who has been attacked with the malware. So this is one thing which we people generally say, but it always happens without our knowledge. Malware comes to our. One is we install protection software. So answer would be like you would say, I've installed antivirus software which can be McAfee, Kaspersky, and so on. So that's one. The next is people actually, when they are trying to have mails, they try to click the mail which is only from the known sender. But it's always a mistake that somebody, and let's say I get a mail, okay, I get a mail with a caption saying that resource person invitation. Okay, resource person invitation. I'm very curious to know who has called me as a resource person, right? So I will try to go and click the mail. But if it happens to be a malware, then my system is also forced to be attacked. Okay, so the captions that comes in the email is very attractive. Right? I'm talking as Senthil Kumar. I'm not talking about you. Let's say I get a mail like that. I would like to click and open, which might become a malware. So it's usually a suggestion is like do not access mails which is from unknown sender. But who is an unknown sender? I think I don't have an answer for it. The next is download files which are only from the internet websites, right? For example, let's take I'm trying to access a PowerPoint. Okay, let's take I go to the internet and I want to have an access on one content, right? Let's take I say preconditions. This URL here, preconditions. Yeah, preconditions programming. Okay, so PPT. I want to access a PPT. I get a lot of URLs here. Some URLs are directly from educational website, colorado.edu. So I can believe that, okay, it's a good content. But let's come down to something like this from SlideShare. I'm not commenting about SlideShare. I'm getting a URL saying slidesfinder.com, right? Slidesfinder.com. If I click this URL, right, and I go to the web page, right, I will not have the direct content. As you can see here, it just gives me some content which is saying just a tag. It is not giving me the presentation which I'm looking for, right? In such cases, what happens is I'm trying to download a file from a website which is not authenticated. So there is a possibility that my system might get compromised. Last, firewalls. I think people know today softwares are having firewalls. You say that you are having a browser. Browser also says, yes, I give you a firewall. You can go and restrict the websites that you want to access, right? The last one, automatic scanning of virus. This I think people will be doing, right? These are the ways in which you can actually protect your computer, right? So how do you conclude that your system is attacked. Okay, possible reasons would be like one, I think people will know your system will keep on restarting again and again. There you can say that there's a possibility that a malware has attacked your system. Then second, you are not able to connect to your network even though you have a Wi-Fi connection. Possible solution they might say that is there's a program running in the background of your computer which is preventing you to connect to the network. There is a malware for it, right? The next, your computer has become very slow, right? Your web browser is not spreading, is not opening faster. There is a possibility for a malware. Then I'm working with this browser. Suddenly it just hangs. It's not responding, right? Then it restarts. That means there's a malware that's happened, right? The next, I see files which is getting modified automatically. I'm not modifying the file. For example, if I go to my folder, if there's a text file, the text file is just not as a text file, it is having some other extension. So that means that it's got modified, right? The next, I'm seeing my programs running. I'm seeing that my programs is allowing my system to turn off automatically, right? So all that are possible reasons for you to say that malwares are there, right? And last, I think everybody will accept your computer is not behaving properly, right? I switch on my computer, less than 1 minute, I want my computer to come on. It is not coming up at all. So I have a doubt whether I have a malware, I have a virus. Okay, that's a last one that you can actually say to say that your system is being attacked, right? So people in the industry, people in the overall process, right, are trying to develop anti-malware programs. These anti-malware programs would be what, which can control a virus, wherein you say antivirus, you call it as an spyware, you say anti-spyware, you develop one for spam, you call it as an anti-spam, you say that I made a firewall, right? That's also going to control your malware, right? So this is the first part which I want you to say to everybody. What is a malware? What are the types of malware? Where are you seeing malwares in real time? Any questions at this point? Participants, any questions at this point?
Participants, any questions? If you have any questions, you can put it in the chat box.
Sir, hello.
Yeah, I'm hearing,
Sir. Yeah. Good morning, sir. Good morning. So far it has been really good, very informative actually. Every time I'm trying to see, like, everything that is happening is, very close to what is happening in the real life now.
Yeah.
First thing is, sir, can we identify or can you suggest some of the good, programs of antivirus or malware which we can, take precautions for? That is first thing. Second thing is the operating system itself is trying to be, prone. Can we use a better operating system? Like maybe is Linux better than or Unix systems better than Windows-based systems? Will that maybe improve our situation? That's exactly what I wanted to ask you, sir. Yeah.
Oh, okay. Two questions, right, sir? Hello.
Yes, sir. Yes.
Yeah. So
First is maybe suggest some. Yeah.
I'll answer to you first. To your first question, with my limited understanding, you can always take any antivirus software which is good and which is economical, right? For example, I take an antivirus which is economical for me, which renews once in a year, maybe with a limited cost. It can be from McAfee or Kaspersky, right? Kaspersky is perfectly fine usually, right? But you know what happens is one virus gets released. Kaspersky will say that, yes, I have a solution. McAfee will say that I don't have a solution. It's a market win-win game, right? Okay. So I answer to my first question would be is like, you can take antivirus software which you feel good, but it can be McAfee or Kaspersky. Okay, sir? Fine?
Fine.
Okay,
so
that's
there is one which is from India, that is Quick Heal, sir. Is that okay? Because some of the shops which I go, they always say buy Quick Heal. I don't know.
Yeah, that is also good. That is also good. That's actually spoken from the economical side also, because it's little cheaper. In fact, in the licensing part, right? Normally, when you go for McAfee like that, if you go for individual license, it's very costly. But it's a university license like that, they give at a lesser cost. What you say is also good, sir. It can also be used.
Okay.
Okay,
Okay.
fine.
Okay.
That's the answer to your first question, sir.
First question. Yes, sir.
Then your answer to your second question, operating systems which is secured and so on. See, actually, this has been already a set story for all of us, right? Windows, Linux is said to be secured. Windows is not secured, right? That's still even the answer, right? That's still even the answer saying that Linux is secured compared to Windows. The reason is, if you go back to the theory of operating systems, the kernel design of Linux is more secured compared to that of the Windows. Okay, so that's one. And next is like any spywares, any sort of malware can actually land in your computer if it is to be a Windows based very easier. Linux is not possible. So that's the reason we say that Linux is more secure. But more than Linux, people say Mac is secure. Mac OS is secure, right? That's why we say that even in the mobiles, Apple mobile is better because nobody can access your data.
Exactly.
Right. And if you go back from Apple, I think people will agree that BlackBerry was famous because the operating system for BlackBerry is so secure that nobody can tamper your data except the server. That's the answer, sir, for your second question.
Okay. Fine, sir. Thank you. Thank you.
Yeah.
It was quite good. Yeah.
Yeah.
Right. Thank you.
Thank you, sir. I have one more question from Kunal Das. My Defender is showing us virus found, but when I scan through the malware bytes, it shows no virus. But when I install a Malware bytes Defender, shows no virus. See, actually, please don't go for Defenders as such. Please go for softwares which is being purchased. I totally have this statement always. Don't go for online Defender softwares. It doesn't help us always. That's the answer for you, sir. Then how is a target computer identified by a malware developer? Okay, it's all how much you have data. For example, you are a person who work in a banking environment, right? And your computer is connected to the banking environment. Malware community wants to look for such data systems because you have very precious data. Okay, so there is no rule for a malware developer to look for computers. It is like, you know, you are allowing your computer to be compromised. As I told you, you see an what is a pop-up icon. You click on it, it gets downloaded. Your computer is compromised. There, even I also have got my computer compromised at one point of time in the beginning, right? And no malware developer targets a computer as such. But you can see the research community, what they are saying from the outside is like computers which are belonging to organizations gets attacked. Reason is there's a lot of precious data which can be stolen, right? That's the answer to, I think, Buzur, yeah, .saraswati@gmail.com. Then Kunal Das, when I scan through Defender, it crashes and it cannot clean it. Why is that? That's again the answer for you, sir, right? It depends on how much your computer is compromised. So my answer would be is like when your system gets crashed, when you're trying to go for the Defender, my request would be is like, please take a backup of your data and format your computer hardware. And that means your hard disk can restart with your original OS again. Okay. Precautions, I don't have any answer because sometimes my computer also has malwares, which is at least a small part of virus. So precautions would be like you can try to avoid accessing of pop-up icons which are showing you some animations for money and so on. So sometimes we see that some pop-up website appears again and again. Is it adware or spamware? Is it dangerous or able to steal our information from our system? Okay, see, this actually comes up. Reason is, see, when you look at the web community, okay, let's take for example, when you look at the web community and let's take you are accessing Yahoo, right? You are accessing Yahoo website, okay? Now, all of us see content of Yahoo with a lot of content coming up. There's some text, there is some videos, there is some animations coming up, right? There is some pop-ups coming up. You can see here, right? This is what I think the person is also trying to ask. So all these pop-ups ads actually carry some sort of attention to the revenue of Yahoo. There's so many ads coming up. Each ad actually pays a small amount of money, right? And ad posting is also a very challenging job in the industry. There's a lot of freelancers who do ad posting. Now, the purpose of that ad posting people is to put content in right places in such a way that you are able to make the person to access that content, right? You can just see, right? So let's take there's an ad post like this. So you are trying to make the person to click, okay, right? So you are trying to create a curiosity to the person. So here, if you ask me a question, is it a malware or not? Sometimes it can be also be a malware, right? But when you are seeing as part of the web page, you need not worry. But if it comes as a pop-up, it comes as a pop-up, right? Like I think people will know, right? In your browser, you'll go and enable pop-up options. That means you will not block your pop-ups, right? That case, you can have a doubt that whether it's a malware, right? So that's answer to Danakar Sharma, right? Okay. Any other questions?
Any other questions, participants? I think you can continue, sir.
Okay, fine. Okay, now this is as a person who steps into malware should know, okay, what is malware, types of malware, and how can you say that your system is protected? Okay, so as I always say to many people, right? You have data, you can afford with more amount of money, you can get powerful computers, you can get powerful servers, you can actually make firewalls also, right? And the firewalls can actually protect your computer better. This is one information I'm leaving to you. Now, the next part of the session, first one, which we want to take through is on the malwares basics. The next one is basic tools for monitoring, right? So as far as monitoring is concerned, there are many tools in the market. Okay, one tool which I suggest to people would be is like there's something called as process control. This is software called as process control software. So as far as the process control software is concerned, it will also help you to understand what is a problem with your computer and what type of softwares are running in your computer. That's one. One second. Yeah. The next software which people should be knowing already is Wireshark. Wireshark is a very good monitoring software. Reason is you will be able to understand what your computer is doing, right? It will be able to give you some information about what your computer is doing. So Wireshark is one of the software that you can actually use for capturing your packets in the network. These two are is not very tough softwares. I think in your networking course also in colleges, you will be using Wireshark. Right? So from general softwares for monitoring, I'm suggesting these two softwares. One is Process Monitor and next one is Wireshark. Then the next question somebody would ask is like, what are the data sets that are there on the internet with which I can start working with malwares? Right? So I'm curious that I want to work on malwares, right? What are the data sets that are there? So let's take through some data sets. So one data set which you can see on the internet is a data set which is your Sherlock data set. So go and paste your URL. You'll find this data set. So in this, you can find data sets relevant to malwares, right? So people have done malware analysis and they got a lot of data sets. You can actually access the data sets. As you can see from this URL, you can actually access the data sets. You can download the data sets. You can get some details about what is a regular sample for a malware, what is a benign sample also, right? So one URL that I'm suggesting for people is the Sherlock dataset. I'll be sharing the slides, so don't worry, just listen and you can clarify your doubts as we move on. The next dataset is a NSL KDD dataset. Okay, whenever you want to you want to create a model, right? So model in the sense, given some data, you want to classify and predict whether it's a malware or not. Then you need some training data, you need some test data. So KDD dataset, that's a NSL underscore KDD dataset, is one dataset which is very good for analyzing the malwares, right? This dataset is downloadable. You can just see here KDD test, KDD train, right? So whenever you want to create any models for classification, you need a training dataset that you can find under KDD train. You need a dataset for testing that you can find under KDD test. Okay, so this is other dataset which I'm suggesting to the people. Then the next one is this one, MTA-KDD19 dataset. So if you go to your browser and type this MDA-KDD19 dataset, right? You will get the paper right? You'll be able to get your paper, and then you'll be able to get your data set, right? So if you can see here, this is a very good data set for understanding traffic analysis, especially with respect to malwares, right? What they do in this one is I'm just coming directly with respect to the data sets, right? They have compared with existing data sets like CTU 13, UGR 16, CCC09, and KDD 99. KDD is what I had showed you just now, right? KDD dataset. So they have come up with a dataset which is called as MTA-KDD19 dataset. With this, they are trying to analyze traffic under two categories. The first one is legitimate traffic, right? Usually when you talk about any type of data set which are captured from the network, it is a log, right? And the log as such will be saved as a PCAP file. If you take a Wireshark also, right? If you say I've just got a data, when you are trying to save your data, it will be captured as a log file. That's your PCAP file, right? So here, if you can find here, it will actually analyze the PCAP file, right? And it will try to categorize whether it is normal traffic or not. So the first type of traffic it analyzes is legitimate traffic, right? The next one is malicious traffic, right? Malicious traffic here, they talk about malicious means what? Anything that is part of a malware is a malicious one, right? So it can be a data from with respect to a virus, or as I told you, virus total. Just now I was saying to people, that's a website called as virus total also. So it analyzes the traffic which is captured as part of different malwares, which can be antivirus softwares, or it can be virus total like that, right? And that they have categorized this as a traffic called as malicious traffic. So here they are analyzing two type of traffic under this data set. One is legitimate data set, legitimate traffic, and next one is malicious traffic. The next one, I think people should be trying to understand that wherever you are trying to create a model, right, for analysis, then your model actually needs some sort of data pre-processing, right? So why do you need data pre-processing? The reason is you are working on data means it's not a small amount of data. It is a data with multiple number of columns. So what can be your data that you can look at? Let's look at the data here, right? What can be your data that you can look at? Let's take your data. 1 second. Right. So this is two data sets that I have taken with my team. So one data set with respect to features, which has got most influence on the botnet. It's basically for the IoT one. And next is UNSW data set, which is again on botnet here. Now, when you open this data set, right, this I'm opening to show you like the extent of features that might come in the data. So the number of features that you have in the data is not going to be 1, 2, or 5 like that. It can have many number of features. So there is a need to understand the features in the given data, right? Features are again columns in the given data, right? Only when you understand the features in the data, you'll be able to create some meaningful understanding about what you want to present from the features, right? For example, if somebody says, what can you talk about a computer, right? People will say that with respect to a computer, I can say that there is a computer ID, right? So a possibility you would say is like there is a system ID, right? Then you would say number of packets sent, right? Number of packets received, right? Then you would say throughput. Right? So I think people know what is throughput, right? I need not give you what is throughput. So you will say that given the packets sent and packets received, I can find the difference and I can speak about what is throughput. So what are your features that you are created here is one is system ID, then packet sent, and next is packet received. And the feature that you are calculating every time is called as throughput, right? So every column of data is going to be called as a feature, right? Only thing is these three features are available, and the feature that you are calculating every time is something called as throughput. Now, what is a feature vector is? Feature vector is collection of features together. So what are your features? System ID, packet sent, packet received, and next is throughput. So if you ask what is your feature vector will look like this. Your feature vector would be given as the set of features separated by comma. So I'm giving the feature vector as like this. Okay. So what is there in your feature vector? System ID, packet sent, packet received, and next is throughput. The next one is something called as dimension. A dimension actually corresponds to number of features minus 1. So how many features you have here? You have totally 4 features, right? System ID, packet sent, packet received, and throughput. So your dimension would be actually given as 4 minus 1, right? 4 minus 1, which will actually say that it is 3, right? So dimension corresponds to number of features minus 1, right? The next one is dimensionality reduction. What is dimensionality reduction is? See, I have 4 features, right? System ID, packet sent, packet received, and next is throughput, right? For classifying my data, if I can reduce this number of features, instead of these 3 features, can I bring it down to 2 features, for example? If I bring it down to 2 features, originally there are 3 features here, at least for understanding. Now it is 2, so the dimension has got reduced, right? So dimension can actually be reduced, wherein the number of features is scaled down. It's got reduced, right? So wherein what you are achieving is something called as dimensionality reduction. So here approaches are there for dimensionality reduction. One approach is PCA, principal component analysis, through which you will be able to reduce the dimension of your data, right? The next is class, right? Given some data like this, system ID, packet sent, packet received, or throughput, I have it meaningfully a set of columns, right? So what are my columns? F1, F2, F3, right? Let me call this as F4, right? So I have 4 columns, right? Now my concern is, do I have a class for it or not? Only when I have a class, I'll be able to analyze the signature of the given data, right? So if there is no class for it, then I have to make use of some algorithms from the study. So there I can use algorithms which are there from unsupervised model, right? Example would be is I can use a k-means algorithm and I'll be able to classify the data. So when I use my k-means for classifying the data, it is classifying my data as 2 classes, right? Class 0 and next is class 1, right? I'm assuming it as a binary class problem, right? That means I can say this is basically a log, right? This corresponds to one row, which is a log of data, where it says that it is being saying that it is an attacked one, right? That means malware is part of the log, right? This is not attacked, right? This is attacked. This is not attacked. This is attacked. Okay? Just walk with me. If you have a doubt, we will always discuss at the in the middle, right? Now, the whole challenge is how do I create my model where I have some features which are part of the data which I want to analyze. What is data here? My network log is my data. So every row in the log, I'm checking whether it is falling into a specific class. So the class will say whether it is an attack or whether it is not attacked, right? Okay. So it's a binary class problem. This is what is called as classification, right? So what is classification malware signature analysis is, given a set of features and the values for the features, can you find a class label for the particular row? If I find a class label, then in that case, I have achieved classification, right? Since the data did not have any class label, I'm showing you like this. I just got the logs, right? How did you get the logs? I got the logs using Wireshark, right? I got the logs using Wireshark. Now, or I got the logs which is there from the internet, right? What can be my source of data? I got my data set available from here, right? From my KDD data set, right? It is not having a class label. So there, the answer would be is like, I need to go for some algorithm wherein we are suggesting an unsupervised model. Example is a k-means. After applying k-means, it is now, after applying k-means, what happens is now my class label is now available. So my class labels are as 1, 0, 1, 0, and 1, right? Now, this is what happens under my training data. So what I have achieved, I've got a classification complete. Now, next step is given my test data. My test data is like this. This is one other row from the log, right? So given my test data, I want to know what is the class it belongs, right? What is the class it belongs? So the class can be either 0 or it can be 1, right? So given the test data, can I find the class to which it belongs? It might say as 1 or 0, but how do I find this is I have to take an approach which is there from the supervised model, right? I have to take an approach from the supervised model. Example of a supervised model can be KNN or it can be SVM, right? And it will say the class to which it belongs. The class value is either 1 or it has to be 0, right? This process is something called as prediction, right? So what you do actually on your training data is what you do is actually called as classification, right? Okay. So this is classification, and given your test data, this is called as prediction. Now, the fundamental question everybody would ask is, see, I don't have any data as training and test data, right? I just had this data entire as one data. I ran through Wireshark or I took my data from the internet like this. When I downloaded my data, right, it is having a lot of features. So how do I take my data? So my data can be something like this, right? My data can be something like this. If you can see it, you will be able to get some meaningful information, right? At least for general thoughts, people will say that this is every sequence of packet that is traveling, right? Every sequence of packet that is traveling. The next one, you can see here, time, flags, then protocol. Everybody knows, right, what a protocol is, right? The next is source address, destination address. Now see the features, right? There are many features. It's not one or two, right? There are many features. Now my challenge is, now given this row of data, right, I don't have a particular class. You can just see here. I need to classify it first. That is, I need to run through a training model. So what are my class values? So here, as I told you, we can use a k-means algorithm, and I can classify my data under categories saying whether it is 1 or 0, right? 1 indicating that it is a log corresponding to a malware, and 0 indicating a log corresponding not having a malware. How will you find it? It's again dependent on the features. So you will have to make some knowledge understanding on what the meaning of the features are. And given the algorithm of a k-means, it can say what class it falls in, whether it is basically a class value as 1, indicating that the particular row log is belonging to an attack, a class value indicating a 0, indicating that the particular row value corresponding to a log is not attacked 1, right? Now, the next question somebody would ask is, okay, I have a large piece of data like this. Okay, how do I run through my model? Usual procedure is, if there is no class label at all, now you can see here there is no class label for your data, right? Now I need to run my training. So usual thing is, out of your total number of records that you have, right, 70% of the records you can take for training, and 30% of the records you can take for testing. I think people can understand, right? If you can go down and see here, total number of records we have is 66,008. Yeah, 6,68,523, right? 6,68,523 is what we have, right? Okay. Now, in this 70% of records, you can take it for training. So your process would be like 6,68,523 into, yeah. So you can take 4,67,966 records for training. Okay. So remaining will come for testing. That's all, right? So you can see here, first one is the training part. So now comes the testing part. So out of my total records, now my training data is ready, testing data is ready. So given some data where there's no class label, now I can say, what's your training data size? It is 70%, right? So 70% of the original size of data. So 4,67,966. Now my test data size is going to be remaining set of records. So my remaining data set of records is 2,557, right? This is how you need to create a model for handling any data. Any data, this is a rule. Now it's a malware data. Again, 70% we have taken for training and 30% we are taking for testing here, right? Now, the next one that we should now get a clarity here is, now we know what is class, right? And then what is classification? Associating a class label. As I told you, the class label that you're associating is either 0 or 1. Sometimes you might have more than 2 classes also. It becomes a multi-class problem, right? So you might have a class label as 2, you might have a class label as 3, like that, right? Okay. Now, classification, as an understanding, people say that it is corresponding to a class. But again, there are two keywords there. One is going to be called as intra-class, and next is your inter-class problems. So what can be an intra-class or an inter-class problem would be is if you take here, right? If you take an data for analysis, right? Let it come up. Yeah. Let's take this one. If you take a data for analysis, if you say there's an attack class called as 1, right? There's an attack class called as 0. It is basically understood as interclass because class 1 is different from class 0, right? But there is a possibility that you can actually say under this, what is the intra-class also, right? So under 1, attack category 1, right? We might have some sub-attack categories. Let's take, we call this A, B, right? So, or C. Fine. Okay. So class label is 1, but your intra-class label is A. Class label is 1, your intra-class label is B. Class label is 1, your intra-class label is C, right? But the other class will not have any intra-class label generally because it indicates that it is not attacked. That's all. But under the attack, I have a different intra-class also under that. This is the next information to you all regarding classification. Classification means associating to a particular class. So under the class, you can specify what type of intra-class also it falls in, right? Okay. Okay. Now, at this point, any questions, please type in your chat box.
Participants, any questions? Please type in your chat box. You can also unmute and ask the question. Any questions, participants? No. Okay, sir, you can continue. No questions? Sir, you can continue, sir.
Yes, ma'am. Just 1 minute. I'm just opening the code.
Sure. Sure, sir.
Fine. So now the next part, what we will be trying to go with is the coding part of how to make models, right? Now with our understanding, we know what is malwares. we know what are the features in malwares. Now the quicker question is would be like, can we start recognizing malwares given a log for us, right? Now, usually it is done in two steps. One is if you are given any size of data, you can actually do a data pre-processing on it. Now, the purpose of data pre-processing is since the features are very larger in size. If you can see here, the number of features that we saw originally from here is very larger in size. There is a lot of possibility that the features will have challenges like noise. For example, if you look at this, all these are character logs, but let's take this as empty. Okay. Now the question would be is like how to fill the value for this particular row is a
Sir, we are
question.
not able to see your screen.
Okay, sorry. One second, ma'am. Okay, now are you able to see, ma'am? Yeah.
Yeah,
Okay.
sir, it's just coming.
Yeah.
Yeah.
Fine. Now let's take this data set like this. If you look at this feature is having consistent values, but all of a
So it
sudden
still is not loaded. It's not able to.
it's not loaded, ma'am.
Yeah. Now I'm able to see, sir.
Okay, fine. So
Okay,
now if
thank
you
you.
look at this feature, there is consistent values in all the rows here. But let's take, for example, one of the column row is not having a value. It becomes a noise, right? Then the next question would be is like when you look at columns like this, where there are protocol values as TCP, UDP like that, you cannot actually compare two rows which are having categorical values like this using any mathematical formula. I think everyone of us know. Now, in such cases, what there is a need is you need to convert this categorical value to a numerical value there, right? So all such things can be done under the data pre-processing part. Now, what we will start looking at is how to do data pre-processing on the given data, right? So whatever data that you're given, we need to do some data pre-processing on it. Now, when you want to do some data pre-processing, one suggestion people generally say is like, you can look at taking all the numerical values and you can scale the numerical values into some ranges of 0 to 1. This is not compulsory, but if you want, you can do a scaling on the values, right? So scaling you can actually do using a function called as min-max scaler, right? Now at this point, if people have a question, okay, I also want to start writing code, and can I also do one with malware analysis or with network logs? Yes, it is possible. So answer would be is like you can actually take you can install Python, right? Python is one which actually has got most of the libraries which are being available. So you can install Python and you can do your code, right? If you feel that no, I want to have a framework which actually installs most of the things, then I have been suggesting this framework last 4 to 5 years. So you can install Anaconda. If you go to internet and type Anaconda Python, you will just get a URL. There you will get a URL for installing on Windows. You can just go and you can download and you can install Anaconda. Now the advantage of Anaconda would be like it comes up with Python directly. So you need not install Python. Then second thing is in case your application is going to have some third-party libraries, right? The third-party libraries would be like, let's take you are interested in having some plots. Let's take you want to have matplotlib, right? This matplotlib is a library which comes with Python, and using this library you can do all the visualizations. As you can see here, we'll see one also in the output today, right? So all these visualizations comes along with matplotlib. So you want to have one like this, then with Anaconda you can install matplotlib and you can get your environment on. So in my system also I've installed Anaconda. So if I go to my command prompt and type Anaconda, you can see a command prompt showing Anaconda prompt. If I click on this prompt, it will get a black window coming up. This is like a console window, what all of us know in the DOS, right? Okay. Now, if I go and type here as Python, it will say me what is the Python version that is available. Version I'm using is 3.7.6, right? But nothing to worry. Any new versions comes up also. You can install the new versions here, right? Whenever you want to install any third-party libraries like matplotlib, for example, you need it to have executable commands, which is either pip, right? So, or you can go for conda. So I'll show you that also. So if you go and type pip, right, it will recognize pip command because pip is installed in my system. So when you want to install a third-party library, let's take, if you want to install NumPy, it's a third-party library. So you'll have to go and type pip install NumPy. It will go to the internet and try installing NumPy from the internet. Okay, right? If it is already installed in your system, then automatically it will say that it is already installed. You can see here, requirement already satisfied, right? So installing third-party libraries to work with the application, you need pip or you need conda. You can either go with pip or you can either go with conda, right? I've installed pip and I've installed conda also. Same suggestion to you also. After you install Anaconda, please install pip or you can install conda for yourself, right? Okay. Then next is coming back to the editor. I need an editor where I can run my code, whatever code that I have, right? So there possible editors that comes with Anaconda is one editor that you'll be getting a Spider. Yeah, you'll get an editor called a Spider. So this editor as such, the advantage of this editor is you can run your Python code. You can see your outputs directly in the editor here itself, right? One problem with this editor is you cannot see any visualization here. For example, if you have a graph, if you have a plot, visualization will not come here. There, what you can do is you can go back to your console. There you can see your visualization. And what I'm talking about visualization means a chart or a plot, all that you cannot see in Spider directly. You can just see it back in your console application here. Okay. Then next one, people generally ask is, okay, I don't write code as a Python file, but I write code as a Python notebook file, right? So this is other thing people say, I have a code, but it's actually on a Python notebook, right? So if you go and type Python notebook, right, they will say that it is having an extension saying IPYNB, right, is an extension for a Python notebook, right? So in case you have a Python notebook file and you want to run it, then that case you can use Jupyter, right? In that case, you can use Jupyter. So Jupyter also comes along with Anaconda. So there you can actually take a Python notebook file and you can run it. Okay. This is small information to everybody to get the software environment ready. So you can have Anaconda. With Anaconda, you can either use Spider or you can use Jupyter, right? Then time to time, you know, what happens is there are a lot of third-party libraries which people introduce on the internet. So you can actually install the third-party libraries. But again, the usage of the libraries is your choice. When you want, you can install it. If when you do not want it, you can uninstall the libraries because it will not take your space of your computer, right? Now, keeping this as one point, now you know the software environment that we are going to work with. Let's move on to the code part, right? So what we want to do is data pre-processing. So let us see what a data pre-processing can actually do. Now, in this, we are taking a small piece of code to show you what the data pre-processing will do. Now, when you look at a code that we generally write in Python, what you see at the top is basically the set of packages that are required. So here, the packages that we are using is pandas. Then the second package that we are using is NumPy. And the third package that we are using is sklearn. sklearn is a very important package. Reason is sklearn gives you most of the machine learning libraries that you want to do. For example, if you want to work with k-means, you will not write a code for k-means here. So, but instead you can have k-means code automatically available. You can see here. Right? It's a machine learning library which is being available. So in the code part, we have included sklearn also, which is import sklearn. The next is Python. All of us know when you want to download a file, you can actually have the file live and you can access, or you can download it to your system and give the path of the file. So we have the file. It's an extension of CSV file. So we are just giving the file name directly here, right? Then next one is label encoder. This one I think people should be knowing already, but still I'm clarifying. If you have a data where the data is a categorical value, you cannot apply any numerical functions on it. There what we do is we need to go for the auto encoder here. So auto encoding, we can actually go for a preliminary level, we can actually do one-hot encoding, right? If you go to internet and type what is one-hot encoding, they will give you a URL and they will say that there is a one-hot encoder which is available in Python. You can see here. So what is the purpose of this one not encoder is this one not encoder as such will convert actually character value like this. Character means the categorical value like this into a numerical value. So wherever you have columns which are basically categorical like this, you can actually convert it to a numerical one by using a one not encoder, right? So even in this code, you can find that we are just calling the function called as label encoder, which will actually convert with any column which is a string. You can see here, right? Any column which is a string, it will automatically convert it to a numerical value, right? Then next one, what we are doing is after doing the conversion, we will want to convert it to a scale value of 0 to 1, right? All columns which are originally available as categorical, we want to convert it to a scale value of 0 to 1. So there we are using min max scaler. And then we are specifying the limits to be 0 to 1. It gets automatically converted, right? So I'll show you the code part for this. This is a code part that we have shown you, right? As I told you, we are trying to take columns. We are checking whether the columns are basically corresponding to string data type. If it is a string data type, we are just converting it to a binary value by using autoencoders. That is a label encoder function is being called. Now we go and run the code. You can see on the right side, the code is running. Now, wherever we had original values, which are basically as characters, right? You can very well see here. This is the original data. This is the original data that we have. Gender is as male or female, and nationality is showing the places where the people belong, and absence days is showing you how many number of people are being absent. But if you take all these three columns, right, after calling through an autoencoder here, that's a label encoder here. So it converts the first column to be numeric. Can you just see first column to be numeric, right? That's your gender. Gender is converted to be numeric. Nationality is also converted to be numeric, right? And student absence days, which is originally as categorical, is also converted to numeric. So the first thing that you should do is, given any data set, including a malware signature analysis data set, there will be surely columns which are basically a string, right? As I was showing you, you can see columns as TCP. If you write go forward, you will have a column with protocol extensions like RST, right? All that. So wherever you see that it is categorical value, so you can see here, this is again categorical. So wherever you see categorical, please convert it to numerical one by just calling this concept of auto encoding here. Auto encoding here in the sense we are talking about one auto encoding here, right? So this is first information to you, which you should do for data pre-processing. Now the second one, which I want you to have a look at is like, whenever you want to take your data and you want to do some more pre-processing, there's possibility that you can actually take every column, right? You can take every column and you can actually transform your column also. Why are we doing our transforming the column here in the sense? See, usually the data falls into some range for every column, right? But when you do a data transform, then it automatically fits to a particular range of data within the overall set. If there are 1,000 records and there is one minimal value and there is one maximal value, all values will fall into the same range, right? So you can actually do the transform part also. So this is the second thing that you can do. As you can see here as such, if you can see in the code part, right? I'll just show you here. So we are calling label encoder. Now it is under the object called as LB underscore make, right? Then what we are saying is for every column, let's take, you say gender, LB underscore make dot fit dot transform. Similarly, for nationality, LBN underscore make dot fit dot transform of nationality. Place of birth, same, LBN underscore make dot fit dot transform of place of birth, right? When you do like this, what happens is it does an automatic fitting of values for all the rows, right? This is a second type of pre-processing that you can do. And the third pre-processing that generally happens, that generally is required, is something called as noise, right? Usually noise as such, as I told you, there is a possibility that there may be a column of data and that column of data is missing. Suppose you see here, this column of data is missing as empty. So you can write a code and you can check whether any column data is missing. If this data column is missing, there are only two solutions to it. One solution is you can actually take a value which is normally occurring, right? As you can see here, the normally occurring value is 100. I can pick that value and I can put it here and I can replace, right? This is one possibility to handle noise. The other possibility to handle noise is sometimes what happens is if you look at the columns, right? Let's take, if you see here, the previous one is, let's take this is 200 and this one is 50, right? And this is empty, right? It is a noise because we understand that every row for that particular feature is supposed to have a value. It's not there, so it is a noise. Now the question is, how do you fill the value? So the solution to that would be is like people say, just take the sum of it and divide it by 2, right? So you say 200 plus 50 divided by 2, right? It will be 125. So I'm just filling the value as 125. Right, okay. So this is the other one that you have to look into. When you are having a log from a malware, please do this pre-processing. One is you have to do label encoder. That's a one-not encoding to convert categorical value to numeric. Then second is you have to do a transform by fitting the value to some scaling value between 0 and 1. The third one is looking for noise. You can look for noise. Noise means which is not relevant, which is empty, right? It is also a noise. And you can try replacing that value using your own way. As I told you, I can take the previous two rows and I can find the average of it, or I can take all the values in the particular column, find the average of it. That is also possible, right? Or sometimes people say that to avoid the risk, you can take the minimal value. The minimal value, let's take is 50. If you can see here, I can go and fill this particular row as 50, right? So this is the first thing that you should do with respect to malware signature analysis, that is data pre-processing. Reason is if pre-processing is correct and correctly being done, once the data is now ready, it is a clean data, right? You are giving it to the model. The model will perform better. But instead, if you're not doing data pre-processing and you're giving it to the model, there is a lot of possibility that the performance of the model may not be better. So that's a first suggestion to all the members. Please do a valid data pre-processing and then start, right? Any questions at this point?
Any questions, participants? If you have any questions, you can unmute yourself or type in the chat box. No questions? Okay, sir. You can continue.
Okay, fine. Now, once you have done your data pre-processing, now the data is clean, right? That means now the data is ready to be executed by the model. That's the next step that we are moving forward. Now comes understanding with respect to the data that we have, right? See, usually we have data from different type of data sets relevant to malware. So here as such, we have taken three data sets. One is UNSW_NB15 data set, then is IoT botnet data set, then NSL KDD data set. From this data sets, each data set are very different. Please understand this KDD data set is different from botnet, and this is different from UNSW dataset, but they have some common features. And all these data sets are corresponding to malwares. Please understand, all these data sets are corresponding to malwares. So we took some common features which are understood to be key features for these data sets, right? Okay. And we were looking at as a multi-class problem. So multi-class problem in the sense, the class label value can be either DOS, or it can be backdoor, or it can be reconsensus. Right? Each of them has their own meaning. Denial of service, backdoor is one type of attack, and next is reconnaissance is another type of attack. So now the question would be is like, what are the common features that we can take? These are the common features that has been taken: protocol, service, state, duration, then category, then attack category, then labels, then sent packets, destination packets, all this. Now people get a question, okay, what is the meaning of all of this? Here we have not created anything. The data sets itself has a full specification, right? For example, if you come down here and you're talking about your packet here, right? This automatically says there is some information with respect to packets, which is PKTS, which is total number of packets, right, being sent. And if you ask what is attack, right? they are classifying the attack under two categories here: normal traffic and attack traffic. That means label as 0 and another label as 1. So there's a complete specification to each of these features under UNSW, right? So what we did is we have taken all these three data sets: UNSW, IoT botnet, and next is NSL underscore KDD, right? And these are the features that are taken for analysis. Okay, this is one homework each one of you also should be doing, right? When you are interested in classifying the malwares, you should be able to go back and see, okay, what is the data that I'm going to take? Let's take UNSW alone. In this, am I going to take which type of features? Which are all the features I'm going to take, right? And this is already classified data. You can see here, the class label is 0 and the class label is 1, right? So you are not going to do any training. You're going to do only testing here, right? Now, once the data set is ready, then the next question is, okay, can I feed it to the model? Yes, you can very well feed it to the model. Once we feed it to the model will run and it will show us a performance. The performance is generally evaluated using all these parameters, which is precision, recall, accuracy, false acceptance rate, and next is false rejection rate. In this, people usually talk about this keyword saying positive samples and negative samples. Now, what is this positive samples? What is this negative samples? If you have a data with yourself, right, and you have classified your data to a specific type of category. Now, you can just see a sample which is understood to be attacked, right? It's a positive sample. That means a class label as 1 is a positive sample. Class label as 0 is a negative sample. So if you ask your question, how many positive samples you have? Here I have 1, 2, 3. 3 positive samples and 2 negative samples. Usually it is a rule saying that number of positive samples should be more, right? Number of negative samples can be less, right? It's up to you to train your model. But what we are interested in more in understanding is like, okay, that the false positives should be very reduced. You might use k-means, you might use SVM, you might use any algorithm which is there in the market. That means I'm in the field of study. But whatever algorithm you've taken, the answer is only one thing. Have you reduced the number of false positives? Right? That's what anybody would ask you. Even if you are a researcher, they'll say you, have you reduced your false positives? Right? FP stands for your false positives here, right? Now, when you look at your performance, performance is evaluated using precision, accuracy, recall, false acceptance rate, and next is false rejection rate. The formulas are there right for you, right? TP means two positives. That means what is true positive is like this. Let's take here. You are in the classification. It is 101101. Now I'm giving a test data, right? I'm giving a test data. Under the test data, I'm trying to predict what is a class label. Class label is 1. Okay, it's a positive sample, right? Now, using the algorithm that I've used, what is the algorithm I've used? I've used a KNN. Using KNN, when I'm trying to test my class sample, it is showing it as 1. But let's take, if I'm using k-means again, please listen. If you have a doubt, you can ask. If I'm using k-means again for this data, right? That's my test data. If it is instead of 1, if it is showing me 0, right? If I believe that whatever k-means I've evaluated is correct. So what is the problem right now? A class sample which is supposed to be 0 is misclassified as 0, 1. Again, I'll repeat. A class sample which is supposed to be a 0 is misclassified as 1, right? So the strength of the model always relies in saying whatever technique we use, the class sample should be classified with the same value. The one class should be classified as class 1 if I'm using some other algorithm also, right? So here if you ask what will be false positive, what will be false positive, it is like this. Here, a positive sample, let's take, you say 1, is classified as 1. It's called as a true positive, right? And the complement to this would be called as a false positive. Again, I'll repeat. A class sample which is as 1 in the prediction phase. With k-means, if I check it is evaluated as 1, class sample as 1, then in that case it's a true positive. If it is complementing to that, you are not getting 1, but if you're getting other value, then called as a false positives. So you are interested in reducing the false positives in any model. So please always make a note. Strength of a model lies in saying that I have reduced the number of false positives. Accuracy is totally different. Accuracy is something like how much accurately it has got classified, right? Okay, that's what accuracy is. So formula you can see here, right? True positives plus true negative divided by total number of positive and negative samples, right? This is a performance measures that we generally take when you're going for techniques like data mining or machine learning. But if you're going to come to the techniques on deep learning, then this would be the technique parameters. Here, precision, recall, accuracy, all are all same. What you might find come across is something called as average precision. See, since your network log that you are analyzing is actually time based in the sense every second you're getting your data. So it is always possible for you to model the data in such a way that it is associated with the probability of classification. I'll again repeat, it is possible for you to model the data and say that it is classifying with a possible probability, right? So what can be the possible probability? It is like this. Let's take you look at your classification here, right? What you see here under the prediction part, it is predicted as 1, right? So let's take it is doing like this. It is saying that it is predicting with higher probability as 1 and lower probability as 0. That means this particular row log, right, as it is given to the model, it's classifying with a class label as 1 with a higher probability and class label as 0 with a lower probability. Next row of data I'm giving, it is saying it is 0 with a higher probability, 1 at a lower, right? Next one, it is saying 1 with a higher probability and 0 with a higher next higher probability, right? So there are some values, right? There are some values here. Don't have a confusion here. There are some values to the state, right? There are some values to the data. Given the values to the data, it is able to say that the values are classifying with some probability of classes. So deep learning will always say that there is a probabilistic score to each of the classes, right? So 1 is having the higher probability compared to class 0. 0 is having the higher probability compared to 1. 1 is having a higher probability in classification for this row compared to 0. If it is a multi-class, it is not 1, 0 and 1 alone. It is having 2 also. What will happen is it will just say what is the stage for 2 also here. So now if you ask a basic question, this row log is having a higher probability of classifying itself as 1. Next higher probability of classifying as 0. Next higher probability of classifying it as 2. This is what happens in the approaches like deep learning or any partial stochastic models like hidden Markov models, right? So if you're going to approaches like deep learning, then the performance parameters that you'll find totally new is something like average precision, top 1 error rate, top 5 error rate, all these parameters you'll be come across. So depending on your model that you use, whether it is a machine learning or a deep learning, choose your parameters. Either it can be this parameters if it is machine learning or machine learning or data mining. This can be the parameters if you're going for deep learning also. If you're going for deep learning, this can be the parameters. Right? So now what we will try to show you to is like what is the algorithm that we have tried, what is the equivalent results that we have got. We'll show you. Just give me a minute. I'm just unsharing and I'll share the screen. Meanwhile, if there's any questions, you can put in the chat box. Let's wait for 2 minutes. I'm getting the code on.
Hello, ma'am. Ma'am, actually, sir is checking for some code, ma'am, so you can wait for 2 minutes. So, participants, if you have any queries, you can just post in the chat window. So, if you have any queries, you can just post it in the chat window so that sir will answer for the questions.
Please wait, participants. Sir will reply to your questions.
Okay, participants, thank you for patiently waiting. We'll continue the session. Okay, right. So as we have been saying, like given the log in front of us, and we want to analyze the log, there are many techniques to do it. One technique, as we have told you, you will have to go and check whether there's a class label for it. If there's no class label for it, please actually take k-means clustering, right? After you apply k-means, you'll be able to classify the data. Then actually you can apply a k-nearest neighbor or support vector machine or hidden Markov model, right? So I'll show you two variants of implementations that we have tried. One with respect to support vector machine, and the second one that I will try to show you is with what we have tried with the hidden Markov model. Reason is support vector machine is basically a kernel-based approach, and hidden Markov model is a probabilistic approach, right? But most closely related to that, people will say that why don't you actually look at possibility of using regression also? Regression is also a good way of doing, but problem here is like we cannot accurately classify the data since there are large number of categorical values. I'm again repeating, since there are large number of categorical values, we cannot accurately classify if we are going for the concept of regression. But solution to everybody would be is like right way of doing a problem analysis would be you can actually do regression also. In regression, you can actually take linear regression, right? Or you can take logistic regression. So if you want to step into modeling of data for any type of problems, please take either linear or you can take a logistic regression. In this linear also, you have categories like multiple linear regression is there. Right. Okay. And when you are using any of this regression techniques like linear or logistic regression, they would come to you with performance parameters saying R square, right? All that you can calculate. With that, you can say whether your linear is better or your logistic regression is better, right? So when you are trying to use any regression technique, naturally you're finding a hypothesis. So the hypothesis that you're finding would be fitting to a line equation. So the line equation would be something like y equal to mx plus c, right? Now, when you're fitting it to a hypothesis, this is a basis for formulating any models for any type of data. Here we are talking about a malware signature data. When you are trying to find a line equation like y equal to mx plus c, it is something like if you have two columns of data, right? Let's take your features are x and y, right? And you have values for the features. Let's take the values for the features to be 1, and let's take 7, right? And you say 2, and you say 8, and you say 3, or 4, and you say it's 10, right? So this is your features, right? So you're finding a line equation for this, which you're saying it as y equal to mx plus c. So your line equation would be something like y equal to 2x plus 5, right? Okay. Now, when data changes, this line equation also will change. So let's take, I go and change here as 17, right? There's a lot of possibility that this equation might become y equal to 2.3x plus 5. So if somebody asks you what is your hypothesis, so your hypothesis is y equal to 2.3x plus 5. So your hypothesis will allow you to classify your data. That's the first information to everybody. Your hypothesis will allow you to classify your data. This hypothesis is what we are calling it as kernel. When you come to kernel-based methods like support vector machine, this is what is called as kernel, right? Okay, so you say your kernel is what? Your kernel equation is y equal to 2.3x plus 5, right? Now, when you are going for any of the regression techniques, so you can very well understand that what are your data points? Data point is 1, 17, 2, 8, and 4, 10. So what are your features? 1, 17, 2, 8, and next is 4, 10. Now for each of this, with respect to your hypothesis is y equal to 2.3x plus 5, there will be an error component that will be calculated, and this error component will be saying how much it is closer to the particular data instance. So error component can be 0.2, this would say is 0.7, okay, and this would say as let's take 0.8. Fine. So if I look at this error component, the least error component is 0.2. That means this data point is very closer to the hypothesis. This data point is very far away from the hypothesis because the error is 0.8. Right? Okay. So this allows you to say that some sample is basically a positive sample or a negative sample. When you say it's a positive sample, then the points are basically below the line, and when points are far away from the line, it's called as a negative sample. So the whole idea of regression would be is like you can get a complete understanding on the data. Given the data, whatever data it is, here it is a malware data, you will be able to understand how the data is spreaded, okay, and you will be able to find out what is the marginal amount of error. So your hypothesis equation regression will change like this: y equal to 2.3x plus 5 plus error, right? So this is your hypothesis equation when you're going for regression techniques, right? If you're going for the same thing in terms of other algorithms, then they would say that you're finding a kernel, right? But when you're finding a kernel, it will not be a line, it will be basically a plane, right? It will not be a line, it will be a plane, right? It will actually say that it is no more, it's a line, it is actually a plane. So example of a kernel based approach is what we talk about is SVM, support vector machine. Okay, this is the next information which I want to say to everybody. All problems can be solved with regression. A regression will give you a hypothesis equation like this, where error will say how much it's closer to the line or far away from the line. The same thing when you come to kernel-based techniques like SVM, this falls into a plane equation here, right? Okay. Now, the next we are now going forward is, okay, I have a data. I'm interested in classifying the data and predicting the data. That's the next question that we have. So let's see how we do the code. As we have told, a Python library automatically has a sklearn. There is a support vector machine library code also available. Only thing we need to spend some time is first in preparing the data. Okay, so as I told you, initially we have taken some steps to prepare the data. So we have converted the data into a data like this. As you can see here, we have taken this columns alone as most important to find the attacks. So we have classified the attacks as DOS, backdoor, and next is reconnaissance. So data set preparation will take some time when you're doing the malware signature analysis. For that, as I told you, you have to go through the specification of the columns. You have to understand what is the meaning of the columns, right? And from that, you can make an understanding which columns are important. So we made an understanding that these are the columns that are important to classify the malwares, right? So our major features are only this. So with these features, we are able to classify the type of attack with respect to malware as DOS, backdoor, and reconnaissance. So you also have to spend some time to go through the specification, pick out the features which are important to classify the type of attack, right? Okay, this is one. Now, next forward would be like, okay, how do we go about with the implementation part? The common procedure is still remain the same, right? So we are looking at a data part and we want to process the data. So the first one that we would be trying to do is we are trying to take the features. So we took the features which are common across the data sets. One second. Right, okay. So as I told you, we took the common features. So the common features we have taken is protocol, service, state, duration, category. The next is S packets, SRC bytes, D packets, and destination bytes. This we came to a conclusion after going through papers that this are the most important features to classify the attacks relevant to malware. Right? Okay. So as I told you, the complete specifications we went through from the data set and we found that features. Then after that, the next question is, okay, let's try with a support vector machine. The reason is already this is a classified data set, right? So we can actually do a supervised model for the test data. So how much is going to be your test data? 30% we can take on the original data as test data and you can apply your supervised algorithm. Here we have used a support vector machine. So the first step, as I told you, you are supposed to do an encoding. I think all of you will agree with me. Now the categorical data will convert it to numerical data. We are trying to use an 1-hot encoder here. The next one is what? We are supposed to do a scaling because we need to normalize all the values to be between 0 and 1. Right? And then the next step would be is like, given the data, we are supposed to convert the data into training data and test data. So training data can be 70% on the original data. Test data can be remaining 30%. Then on the test data, apply support vector machine algorithm, right? Then compare what you got as results, right? By checking with the class label. With that, you will be able to say whether your classification is improved or not, right? Now, let's walk into the code part. Yes. So, I think people should be able to see. Ma'am, are you able to see the code? Hello?
Sir, yeah, now it's clear, sir. Little
Okay.
more if you could zoom in.
Okay, ma'am.
Yeah, yeah, fine.
See here, as I told you, you need specific libraries. So one is sklearn, pandas will be automatically required. NumPy will also be required. You want to do some pre-processing, so you will invoke pre-processing under sklearn. Another one which we are using here is pickle. Pickle is also other important library that you can include in your code. Then next, we want to work with support vector machine, right? So we are saying from sklearn.svm import svc. So this will allow us to use support vector machine codes in our program. Then the next one that we are now looking at is a data set, right? Okay. So data set, we have prepared our data set as what we want. So we have categorized the data set as data sets which are influencing the classification of attacks. So yes. Okay. This is the full spec data set. Okay. Then other data set. Yeah. Right. Other data set is a influencing data set. So this data set we prepared from the original source of the data set. Now the data set is now available. Okay. Then after that, as I told you, we need to take certain columns which are not required, right? Because all columns we are not interested in processing. As I told you, we need only the features that is meaningful. So we don't want to have these columns like protocol, source address, packet sequence ID, destination address, source port, destination port, because we are not looking at basically process level analysis. Right. This is one other thing which is now coming up very well in the research. Right. People are talking about, can you look at process level attacks? When you're looking at process level attacks, then you can look at the port numbers, then you can look at the address level information, even you can look at the protocols more in detail. Since we didn't look at the process level attacks, we don't want to have that column, so we drop that columns, right? Let's see that, yeah. So this is the data set that we had got now, okay? So in this data set, as I told you, we do not want to have certain columns, protocol, then source address, source port, destination address, destination port, because this is not meaningful to classify the type of attack since we are not looking at process level attacks. So we dropped all that in the as columns in the code itself. You can see here, df is nothing but the data frame object. So df dot drop that particular columns, right? Then we called on the encoder, right? We called on the encoder, right? And we are looking at classification of attacks here. So we want to have a category of type of attacks as DOS, distributed denial of DOS, then normal, theft, and next is reconnaissance. So if you ask like how many type of classes that we have looked in here, we have looked at 5 type of classes. Class 1 as DOS, class 2 as distributed denial of service, class 3 as normal, class 4 as theft, and class 5 as reconnaissance. Right? Okay. Then after that, what we started doing is we started looking at calling the code for the classifier, right? So before we call the code for classifier, we need to do the training and testing part. So originally the data is now available. If you look at this data, you can just see here, this is the data, right? Okay. So if you come down here, it's having the meaningful information for all the columns, right? So we want to classify the data. So we split the data into training as 80, testing as 20. So if you want to change this also, you can go and change. You can say testing can be 70%, 30%, right? Testing can be 30%. So training becomes 70%. So anything higher than 70 is acceptable. That's what research articles say. So here we have tried it with the last iteration we have tried is 80-20, 80 for training and 20 for testing, right? Okay. Then next what we do is we call on the classifier codes, right? As we can see here, we are calling on the support vector machine classifier. In this, usually people generally ask what type of kernel you want to have, whether it's a linear kernel or a non-linear kernel. Generally, SVM is for linear classification, but now we have got ensemble classifiers on SVM, which can do non-linear classifications also, right? Here we are trying to call only a linear kernel, so we specify the kernel type to be linear. So you can see here, kernel to be linear. Then after that, what we are trying to do is like once we are trying to do the classification using SVM, Then we try to classify and we try to save the file into a new file name, which is your unsw_svm model.sav, right? Because after we do the classification, we want to save it to a file name. So file name given as unsw_svm model.svm. Then what we do is we call the prediction code, right? So under prediction, what we are trying to do is we are trying to take the test file data, right? Under the test file data, you can just see, right? We are trying to take the test file data and we are trying to predict the class it will fall in, right? Once it is done, then we check how much amount of accuracy classifications have come up and we can see the output, right? So the outputs that we have gathered is like this. The accuracy we have got is 0.88, that means 88%. So this is how the metrics can be presented always. Now we have looked at 5 classes, right? So class values as 1 to 5. As I told you, DOS, distributed denial of DOS, normal, right? We said all the 5 class values. For each of the class values, we have found the precision, recall, F1 score, and support. Same, we found the average also, average accuracy also. Average accuracy score is coming to 88%. That means with support vector machine, the average accuracy we have got for this log is 88%. Then the next metric, which everybody would be interested to look at, is the confusion matrix. You can also look at your confusion matrix also to say how much amount of misclassifications have gone behind the data, right? So this is one code which I want you to see. Then the second code which I want you to have a look at, which we are trying now, is looking at possibility of using hidden Markov model, right? All of us know the strength of hidden Markov model, right? It's basically a state-based model. So when you look at this data, right, a hidden Markov model will start asking, okay, what are your states, right? So next somebody would ask from the hidden Markov model, what are your hidden states, right? So then people ask you, what is your transition matrix? So these 3 keywords are always there: normal state, hidden state, and next is transition matrix. And last, people would ask you is like, what is the emission error when you're going for hidden Markov model? This approach we have just started. We are in the process of experimenting the possibility of hidden Markov model. But I'll show you the results what we are getting as of now. See here in this we have taken all the columns, right? Okay, we have taken all the columns for analysis. So we are trying to first analyze it using hidden Markov model. But here the type of data set that we have applied is a different data set, that is KDD cup data set. Right? I told you in the beginning itself there's one more data set called as KDD data set. Here we have taken a KDD data set. Then we looked at the parameters and we have applied HMM. So when you want to go for hidden Markov model, there's a package library called as HMM. In that you can actually use HMM learn. So using that, we are able to classify the attacks and normal category. So now we have done only binary class problem. Earlier the example code what I showed you with SVM is under 5 classes, but this is only under 2 class. A class 1 as attack and class 2 as normal. And here we are calling a Gaussian HMM, right? And then we are fitting the features. I'll show you what results we have got. Right, okay. Yeah. Right. So this is a final set of results for each attacks categories. We were able to say that, okay, which are all the logs which are classified as attacks, which are all the logs which are not classified as attacks, right? That means it is normal. But the limitation of the work that we have completed until now with HMM is it's only for a binary class, but you know very well, at least from my session, that it is not binary class, it is multi-class, right? DOS, denial, distributed denial of service. So you'll have to look at a multi-class problem approach for HMM. Then the next thing is we have left to the library. If you can see here, no, the library that we have used is HMM. HMM learn library will take care of doing all this, right? But the ideal possibility scope would be like, given the features, we should be able to say which are all hidden states, right? And we should be able to find the transition matrix. So that sort of a mapping that we have not done, we are in the process of doing it, right? So this is what I would like to show to you from the HMM side, hidden Markov model side. And next forward, somebody says, I'm interested in extending this to deep learning model, then that case you will have to bring in many other parameters. If somebody says I want to do it in deep learning, then this is one UI which everybody knows to quickly understand what deep learning is, right? So playground dot TensorFlow. So if you're going for deep learning, then naturally what will happen is like you will have to speak about what is your learning rate, activation function, what type of regularization you're using, and regularization rate, right? Then you will have to speak about layers, hidden layers, how many neurons you're going to have in each hidden layer, right? Okay. Then you will have to say how many epochs you're going to provide. And every time what will be calculated is the test loss and training loss. Right? Precision accuracy is all secondary. What you will be calculating is a test loss and training loss. This will be more connected to the error. Right? This will be more connected to the error component of the given data during classification. And as you are trying to speak about deep learning, they will ask you like, okay, what are your general parameters? What are your hyper parameters? Right? And what is your stopping criteria for fixing the epochs? And it will converge, and it will say at one point that the training loss and test loss has matched. That means the loss becomes minimal or the training loss and test loss becomes the same. That at that point the model will be getting created. So that's the next shift that you can always look at, right? When you have malware's logs for analysis, you can always look at deep learning also as a solution. So that we are doing, and the journey is going on to try to make more better results with the malwares. That's it from my side. So thank you so much to the management for giving me the opportunity, and thanks to your principal and the coordinators for the opportunity being given. If there's any questions, surely I'll take it up.
Any questions, participants? There were two questions which were posted earlier, sir. So
Yes, ma'am.
one is, sir, any malware removal tools? And one more is, please provide the list of tools for cyber forensic with its description in PDF format for the participants.
Okay, sure, ma'am. I'll share you the list of cyber forensic tools with its purpose. I have made some document. I just put it to a table and share it to you. You can share it to the participants. And first question, I think what you are asking is the malware handling tools. Am I right, ma'am?
Correct. Removal
Yeah,
tools.
malware removal tools, it's again depends on the type of malware. If it's a spyware, you have to go for anti-spyware tools. Most commonly, what people can do is you can have your antivirus software that will take care of removing most of the malwares. Because at the academic level or at the individual level, we work only on individual PCs, right? Or at least on our laptops we work. So there you can preferably go for an antivirus software.
Any other questions, participants? Any other questions? I think nothing else, sir. Yeah, there's one more. Name some free software which identifies. Just a minute. There are many. Okay. Name some software, free software which identify that my mobile has malware. Sir?
Actually, there is no free software which can actually find malwares on the mobile. Actually, it's left to the operating system of the mobile only. So each proprietary brands, they say that they have their proprietary operating systems which will take care of the malwares.
Any other
Ma'am,
questions? Yeah, I heard someone speak. You can speak. I think that's it, sir. No more questions. Anybody else wants to speak? You can speak. You can ask questions. Okay, there's one more. Is there any GDPR related mandates in our country so far?
I'm not getting them. Can they be clear?
Is there any GDPR related mandates in our country so far?
Yeah, actually, the government is putting up something in force actually. So it is there, ma'am. It is there.
Are there any more questions? I think that's it, sir. Thank you so much for such a interactive, informative session, and also the tools and the hands-on session which you provided, which is very good and for the participants who are taking up research, and it's a lot of information who really want to explore in malware. Thank you so much, sir.
So thank you from my side. Thanks for the opportunity given.
Sir, one
thank you.
person wants to speak to you. Sir,
Yeah,
you
yeah,
go ahead.
please.
Sorry. I think I came in at the last moment now. It's
No
not a question actually, it's a request to the organizers. This particular session needs a little, practice, madam. And if we can share it's being recorded, right? If
Yes,
it is
sir.
being
Yes.
recorded, can the recording be shared so that we need to refer to this thing again and again? We need to actually practice every step actually. Sometimes
Yes,
that's all we
sir.
are trying to look at it. So that is a request. It's not a question actually.
Yeah,
It's a
sure. We are
request to
recording it
provide
and
the
we will be
material.
uploading.
Yeah, please share the recording so that it will be easy for us to follow.
Yes, sure, sir.
Yeah, thank you, madam. Thank you. Sir, session was really good. Only thing is that we need a little practice, sir. That's all. It's
Yeah,
little
thank you.
slightly technical.
I understand. Maybe
yeah, it's technical, so we need to practice, sir. Yes, sir.
yeah, maybe at the maybe the next part of the session, I'll try to share what is the software that you can install at your host machines. So if you can keep it ready, we can parallelly share the code. We can make you run also. That's also possible.
That will, yeah.
That's also
Yes,
possible.
sir.
I can
We will
get the data
inform.
upon the hub, right? I can put it to the Google folder. You can download the data part and keep it. Code by code, we can run, and you can keep your demos also parallelly.
Correct. Because we can follow you step by step then.
Perfect.
So what is happening here is only observing you what you are doing.
I understand.
Right. So
totally
at our end, we are very static.
I understand.
Okay. Right, sir. Yeah. Yes, sir.
Yeah. So
Right,
maybe
sir.
we can do like that, ma'am. In the next part, I'll share you the data folder and the code folder in the GitHub, or maybe in the common Google folder. People can download and keep it. Keep their softwares also installed, Anaconda, Spider, set of libraries. Then as we teach, they can run and see also. That also we can do.
Yeah,
yes, sir.
That's a very good suggestion and a very good method, sir. Yeah.
Yeah, done, sir. Then we can do that. We can do that.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you, ma'am. Thank you so much. Thank you.
Yeah, thank you, madam. Thank you.
Thank you. Announcement for the participants. The next session will start at 2 o'clock. Okay, and towards the end of the session, we'll have the feedback link also. Please make sure that you will enter the feedback link and then only leave for the day. So the next session will start at 2 o'clock. Please join in. The same link will be provided. Thank you, participants. Please join in by 2 o'clock.